For today's lesson, our focus standard comes from Grade 7, Expressions and Equations, Standard 4B. Solve inequalities, graph the solution, and interpret it in the context of the problem. Our topic is from our Simplifying Expressions and Equations unit, Inequality Math Stories. Our essential question is, how do we translate inequality math stories and interpret our solutions? Please take a moment, pausing the video if you need to copy the topic and the essential question into your header, along with today's date. Set up your question column and your note column, and resume the video when you're ready to begin. So this is going to be a video with lots of writing, so just know that ahead of time. And we're going to start with this reference chart. So here I've listed the 4 main categories of inequalities: less than or equal to, greater than or equal to. And in each column, I've listed some words that are commonly used in math stories to represent these inequalities. And they're a really important reference to have. So I'd like you to pause the video here and make sure that you copy down each of these examples. Now this is not an exhaustive list, and so you may want to leave room to be able to add more as you find them in story problems, but these are a lot of the most common. Once you have these copied down, let's move on to our first problem. So here's our first math story, and I definitely want you to copy it down because I want you to pay attention to the key words that are in the story problem that help us write the equation. So Stella went to Oaks Park with $20.75 to spend. She bought lunch for $5.75 and wants to spend the rest of her money on tickets for the rides, which cost $1.50. What is the maximum number of tickets for rides that Stella can buy? Use T for the number of tickets. So think this problem over, pausing the video if you need to, and see if you can pick out what is the information and how are we going to write it as an inequality statement so we can solve to answer the question. Resume the video when you're ready to check your inequality statement with mine. Here's the inequality I wrote. I used the $20.75 that she has to spend, and I said that that was greater than or equal to what she's actually going to spend, right? Because she might spend less than the $20.75 if it doesn't work out evenly for her to have lunch and buy a bunch of tickets, or it's going to be exactly equal to $20.75. Also, it's using the word maximum. Maximum says that we use the less than or equal to sign, so my variable is on the less than or equal to side of that inequality. So now that we have our inequality written, please go ahead and solve it, and then check back when you're ready to compare our work. Well, since $1.50t is the term with the variable, I work to first zero out $5.75, and I did so by subtracting $5.75 on both sides. That left me with $15 is greater than or equal to $1.50 times t. To get t by itself, since it's being multiplied by $1.50, I divided both sides by $1.50. And 15 divided by $1.50 is 10. So 10 is greater than or equal to t. I can also think about this from the variable standpoint. T is less than, since that's the side I'm reading it from with the variable, less than or equal to 10. This might make it a little bit easier to graph on our number line. So if you haven't done that, go ahead and graph our solution on the number line. It should look like this. T is equal to or less than 10. Now we could talk about this and say, well, really this arrow should stop, right? Because there's no way that she's going to buy -3 tickets. So really we could stop at 0 and write a more complete inequality statement than this. But based on the work that we solved here and our inequality that t is less than or equal to 10, then this is how it would look on our number line. Let's go ahead and look at the next problem. To snow, the outside temperature can be at most 32 degrees Fahrenheit. The temperature is currently 41 degrees. If the temperature drops 2 degrees every hour for the rest of the day, in how many hours will it be cold enough to snow? Use H for the number of hours. So once again, please copy down the problem, paying attention to the important details that help you write the inequality statement. And then check back to see if we agree. How'd you do? Since 32 is the maximum temperature that it can be to snow, I wrote that on one side of my inequality statement. And then I took the current temperature, 41, and since it says it drops 2 degrees every hour, used a -2 or -2 times h for the hours. Now, let's solve it. Go ahead and try to solve this inequality, and then let's check and compare our answers. Well, if you got that you think it will be cold enough to snow in 4.5 hours, or more than that, then I'd agree with you. Couple of things. First, we had to subtract 41 from both sides to get -2h by itself, which left us with -9 is greater than or equal to -2h. And then we divided both sides by -2. Remember, that's a red flag that tells us that we have to flip our inequality sign. So 4.5, which is -9 divided by -2, is less than or equal to h, which stands for our number of hours. At 4.5 hours, it could be cold enough to snow, or any number after that, assuming that it is still dropping or remains below 32 degrees. Graphing this inequality on our number line would look like this. We would put a solid circle since h is greater than or equal to 4.5, and since h is on the greater than side, it's being eaten by that crocodile, then we shade everything to the right. I think you're ready for the third problem. Number 3. In order to be able to dive in the deep end of a pool, the water level must exceed 16 feet. The pool water level is currently 7 feet. If it is filled at a rate of 1.5 feet per hour, how long will it take to be ready for the diving competition? Use H for the number of hours. Again, please copy down the math story and pay attention, maybe even underline some of the key information and words that help you write the inequality statement. And then let's check back to compare. How'd you do? Well, since it said it must exceed 16 feet, I used the greater than symbol, that this side of my statement is representing the water level, and it must be exceed 16. So 16 is on the low end of that water level that makes it safe for a diving competition. Since the water level is currently 7 feet, I added to that the rate 1.5 feet per hour, so a positive 1.5 times h. If you haven't done so already, please solve this inequality and graph it on the number line, and then we'll take a look and see if we agree. How'd you do? Well, following these steps and that we've been using to solve inequalities, we should have gotten the answer h is greater than 6. So it'll take more than 6 hours to fill the pool and have it ready for the competition. If you didn't get h is greater than 6, please check back over your work and compare to mine. Graphed on the number line, we'd have an open circle at 6 since h is greater than but not equal to, and shade everything to the right. On to our fourth and final problem. Miss Lossner took her dog to the vet and was told that her dog needed to get down to the target weight of 65 pounds. Her dog weighs 80 pounds, and the vet set a goal for her dog to lose 3 pounds a week. At that rate, how many weeks will it take for a dog to be below the target weight? Use W for the number of weeks. And go ahead and see if you can write an inequality to model the situation. Let's compare. I wrote the inequality that 80 minus 3W is less than 65. Now, let's solve it. How many weeks do you think it'll be? Well, after I solved this inequality, I came up with the answer that the number of weeks is greater than 5. It'll take a little over, if not more, than 5 weeks for her dog to be on the target weight. Notice that in this last step, you had to divide by -3. So we went from using the less than symbol to the greater than symbol to make sure that we had an inequality that would give us a true statement. That's going to complete our video lesson on math stories using inequalities.